Welcome back. Welcome to this brand new DevOps tool, Terraform. Terraform is an IAC tool, Infrastructure as Code tool. Earlier, we talked about infrastructure as code. We would want to automate the provisioning of servers on the cloud. We would want to be able to install software on them, and we would want to be able to deploy applications to them. Where does Terraform fit in with respect to infrastructure as code? Terraform is typically used to provision resources on the cloud. You can provision virtual servers, you can provision load balancers, you can provision storage, you can provision databases. Typically, Terraform is used to do server provisioning. Terraform also provides a few basic features to do server configuration, but typically the best practice is to use Terraform for server provisioning. The installation of software and configuring the software is typically left over to configuration management tools like Chef, Puppet, and Ansible. Now, let's look at what you'd need to get started with this specific section. The first thing that you would need is a AWS account. I would recommend you to go to the section getting started with AWS and create a AWS account. We will create a number of resources on AWS. We'll create EC2 instances, S3 buckets, we'll create IAM users, and a variety of things on AWS. So go ahead and create your AWS account. Number two, you would need the IDE Visual Studio Code. If you have not yet installed Visual Studio Code, you can go to the section getting started with Visual Studio Code and install Visual Studio Code. The third thing that you would need, obviously, is to install Terraform. How do you install Terraform? Installing Terraform should be a cakewalk. All that you need to do is to search for install Terraform. You'd land up on this page on learn.hashicorp.com/terraform getting started install. So once you go over there, on this page, you'd see a couple of videos to help you install Terraform on Mac OS and Linux and Windows. So based on your specific operating system, you can choose the video and you can follow the instructions in there. You'd see that installing Terraform would be very easy. All that you need to do is to go down, choose the appropriate package based on your specific operating system. So there are multiple packages available based on your operating system. So you can download the specific package for your operating system. Terraform is actually distributed as a single binary file. So all that you need to do is to download it, unzip it, and you would need to move it into your path variable. Make sure that the Terraform executable is added in to your path variable. Once you successfully install Terraform, when you do a Terraform version, you should see one of the latest versions of Terraform. So go ahead, get your AWS account, get your Visual Studio Code installed and Terraform installed, and I'll see you in the next step. Welcome back. In the previous step, we installed Terraform. If you launch a command prompt or terminal and type in Terraform version, you should see one of the latest versions of Terraform. Any version which is greater than 12 should be great. And if you type in Terraform -- version, also you should see the specific thing. Now, what do we want to do using Terraform? We would want to create resources in the cloud. And the cloud provider we would be using is AWS. So we'll be creating a lot of instances, a lot of resources in the cloud. We will start with playing with basic instances, like let's create a few IAM users. Let's create a few S3 buckets. Let's create a few EC2 instances and all that stuff in the cloud. If you're not familiar with S3 buckets or EC2, don't really worry. We'll talk about them a little later. For now, let's get started with creating a new Terraform project. What I would recommend you to do is to create a folder called Terraform somewhere on your hard disk, and you can go into Visual Studio Code and open that folder up. The way you can do that is by just saying file open and choose the Terraform folder. This folder is empty right now, so let's go ahead and open it. So this is the folder which we are looking at right now. It's an empty folder. It does not really have anything in here. And over here, I'll create a new folder. I'll call this 01 Terraform Basics. So let's start creating a new file in here. Right click, new file. Now In Terraform, you'd write a lot of configuration. We would want to create a few resources in the cloud. We would want to create a few resources with AWS. And in Terraform, you write the configuration in files with extension TF, Terraform, TF. So I'll call this main.tf. So main.tf is the file where we would want to write in all the configuration. And which cloud do we want to talk to? We would want to talk to AWS. And in Terraform, if you'd want to talk to any of the cloud providers, you'd need something called a provider. So I'll start with provider. Which cloud do we want to talk to? AWS. There are a number of providers that Terraform provides. Among them, AWS is the one which is used to talk to Amazon Web Services. And when we are talking to AWS, we need to specify something called a region. If you look at the cloud, each of the cloud providers would offer multiple regions. In each of the continents around the world, there would be multiple regions. By having multiple regions around the world, you can provide your users high availability. So you can deploy your applications into all these regions and you can actually provide high availability. If you do a Google search for Terraform providers, you'll land up on this page, providers Terraform by HashiCorp. HashiCorp is the company which created the tool Terraform. You can see that there are a number of providers that Terraform supports. So AWS is here, Azure is here, the Google Cloud Platform also would be somewhere down here. So there are a huge number of providers that are provided by Terraform. As it says in here, a provider is responsible for understanding API interactions and exposing resources. So whenever we would want to create a resource or we would want to get any details about a resource in the cloud using Terraform, we would want to use a provider. The thing is, all these providers are not really downloaded as part of your Terraform installation. So when you installed Terraform, all these providers are not part of the installation. And therefore, what we would need to do is once we add a provider like this, we need to do a Terraform init, which would actually download the provider onto your local machine. How can we do that? Let's do that right now. So we did a Terraform version. What's the present working directory? I'm inside microservices. The directory I would want to get into is this Terraform basics folder which we have created just now. So the place where we have the main.tf created. So I'll do a cd and the present working directory is now Terraform basics. And if I do a ls or a dir, you can see that there is a file called main.tf. And now over here, I can do a Terraform init. You can see that Terraform init does something called initializing the backend. We will talk about what a backend is a little later. For now, you can see that it's initializing provider plugins. We configured AWS as a provider. So what it's doing is it's downloading the plugin for the provider AWS. So for each of the providers, there are different plugins available. And right now, what is happening in the background is the provider for AWS is being downloaded. And you can see that this specific version which is downloaded is 2.46.0. In Terraform, you can also specify that I would want minimum this version of something. So I can go in here and I can specify that I would want at least version 2.46 of this specific provider. Now, if you go back to the folder Terraform basics, you would see that there is a folder called .terraform. This is a hidden folder. So make sure that you go into the hidden folders and you'd be able to see something called Terraform. And over here, you'd see plugins. And inside the plugins, you can see the Terraform AWS provider in here. You can see that the size of this is really huge. So if you are creating a number of Terraform projects, these .terraform folders might take a huge amount of space. In this step, we created a simple project for Terraform and we initialized the provider AWS. There are a few prerequisites before we would be able to use the provider which we have configured to actually talk to AWS and provision resources. I'll see you in the next step. Welcome back. We would want to be able to talk to AWS from the command line. We would want to be able to look at the resources in AWS and play with them from the command line. And to be able to do that, we would need to be able to create a user and get the access keys for them. What we'll do is we'll go to services and search for IAM. You can log into management console and search for IAM. And in IAM, go down to users. And what I would do is I'll create a user. So I'm doing an add user, and I would call him command line user. And I'll provide only the programmatic access, only the access using access key ID and secret access key for this specific user. Next, I'll go to the permissions. What I'll do is I'll take a shortcut and I'll attach existing policies directly. To help us quickly get started, I'll provide him with administrator access. Be cautious in providing administrator access in production because he would get access, this specific user would get access to everything under your AWS account. I'll go ahead and click next. And I don't really want to add any tags. I'll say next review. And I would go ahead and say create user. So we have just now created a user. At the time of the creation of the command line user, you can also see that an access key ID and a secret access key is assigned. You can actually download this CSV file which contains the access key ID and the secret access key so that you have a backup of it. One of the most important things is if you lose this access key, you will not be able to retrieve it back. You would need to create a new access key, but you'll not be able to get the existing access key back at any point in time. So if you want to save these access key details, you need to save them. What I'll recommend you to do is to download the CSV file and have it ready. We'll make use of these details in the subsequent step. I'll see you in the next step. Until then, bye-bye. Welcome back. In the previous step, we created the access key and the secret access key so that we can actually talk to AWS from Terraform. In this step, let's configure these as environment variables. Now, if you do a Google for Terraform Provider AWS, you should land up on this specific page, Provider AWS, Terraform by HashiCorp. Over here, you can see a few examples of how you can use the Provider AWS. We have already configured this version and the region. We are using US East 1. One of the interesting things about AWS regions is different regions have different features. So US East 1 is one of the first regions where all new AWS features are deployed to. So it's actually an exciting environment to play with. Now, if you scroll further down, you can see that there are a number of ways you can provide your authentication credentials. One of the options is to use static credentials. However, the thing is, these static credentials are not really recommended. You can put the access key and the secret key directly in your Terraform scripts. Over here, I can say access key and secret key right here and provide these details. But the thing is, the Terraform scripts are typically stored in version control, and you don't really want to store your access keys in version control because they might be misused. So what we'll do is we will use the environment variables approach. So we will create environment variables and set up the credentials. Let's see how to do that. We already checked that we have Terraform installed. So the way you can set up the environment variables is export AWS access key ID is equal to, so you need to get this exactly right. So it's export AWS underscore access underscore key underscore ID is equal to, and use the access key from the management console. In the previous step, we created the access key and the secret access key. So you need to go there and copy the access key ID. So the first one which we are copying in is the access key ID. The next thing that you would need to configure is export AWS underscore secret underscore access underscore key. AWS underscore secret underscore access underscore key, and the value for this you would see it when you click show. You can also download the CSV files and you can find the secret access key from that as well. So I'll copy this up and paste it down here and press enter. So I've got my environment ready. So I have an access key ID and a secret access key configured. How can we test it? Let's try and create a resource in AWS. Now, what resource do we want to create? Let's create something called a S3 bucket. What is an S3 bucket? Let's search for S3 in here. So I'm going to services and searching for S3, and it says scalable storage in the cloud. Let's click it and go down there. So we're going to the S3 management console right now. Let's try and play with this a little. Now over here, if you click the documentation link which is present in here, you can see that AWS Simple Storage Service, S3 stands for Simple Storage Service, is the storage for internet. So you can use Amazon S3 to store and retrieve any amount of data from anywhere on the web. The way you can actually think about S3 is like a file store. You can provide a key and store a file against it. And the amazing thing about S3 is that it provides you high durability. That means once you put some data in there, there is very, very, very less chance that you would lose it. AWS S3 provides 11 nines durability, that is 99.99s. And it also provides high availability. It provides 99.99% availability. So if you want to access S3, it's available 99.99% of the time. S3 is typically used to store files, to store backups, and a wide variety of other stuff. Now over here, I've closed the documentation window, and over here, now let's try and create a S3 bucket. You can create a S3 bucket and store a lot of files in it with a key value mapping. So let's go ahead and create a S3 bucket. You can see that the name should be DNS compliant. That means the name can only contain alphabets, numerics, and hyphens. So let's say I create a bucket by the name bucket. Can I create a bucket with the name just bucket? Let's say create in here. You can see that it says bucket name already exists. The interesting thing about AWS S3 bucket names is these should be globally unique. I mean, it's not just your AWS account. They should be unique across all the AWS accounts in the world. So you cannot reuse a bucket name which is used by somebody else. So that's the reason why typically when you create a bucket name, I would actually add in bucket, let's say in 28 minutes, and let's say another unique number. So this would enable us to create a bucket. And once you create a bucket, you'd be able to add files to it. So I can take this bucket and you can upload a file. So you can take a file, upload it, and you can actually do a lot of stuff with it. Now, we are not really interested in uploading a file and stuff to S3. What we want to do is do the same thing using Terraform. So you want to create a S3 bucket using Terraform. How do we do that? Let's get started with it. We would want to create a S3 bucket, and whenever you want to create something in Terraform, you would want to use something called a resource. A resource is an object you would want to manage in the cloud. And to be able to use a resource, there are two important things that you need to provide. The first one is what is the type of the resource. The type of the resource is S3 bucket. So S3-bucket. In Terraform, typically the resource type will also include the cloud provider name. So the provider name underscore the resource type. So AWS underscore S3 bucket. Whenever you want to create a S3 bucket or manage it, this is how you would put it in here. Now, the next name is very, very important. This is the internal name that you're giving in Terraform. So this is the Terraform name for your bucket. So whenever you would want to refer to this bucket in Terraform configuration, in this configuration file that we are creating, whenever you'd want to refer to this bucket, this is the name that we are going to use. I'll give it the name my S3 bucket. So this is the internal Terraform name. Now, when we create the bucket in AWS, we would want to give it a name. Earlier, we created a bucket with the name bucket in 28 minutes, 1, 2, 3, 4, 5, 6. What do we want to create a bucket in here with? We cannot create a bucket with the same name because buckets are globally unique. So what I'll do is I'll do bucket. So that's the attribute that you need to configure. So you want to create a AWS S3 bucket with the name. What's the name? My. Can I use underscores? The thing is, as we looked at earlier, underscores are invalid characters in the bucket names which we are creating in AWS. That's why we have to use hyphens. So my hyphen S3 hyphen bucket, and add in things that would make the whole thing unique. So I'll say in 28 minutes hyphen Ranga K hyphen 001. You can add anything that you think will make this entire thing unique. So we would want to create a AWS S3 bucket with this specific name. Let's check the present working directory in here. So I'm inside the 01 Terraform basics, which is where this specific main.tf file is present. So if I do ls or dir in here, I'll be able to see main.tf, and I've made sure that this is saved. And over here, I would want to execute this command. In Terraform, typically we use a two-step execution approach. First is plan. We will check what would happen. So a plan would tell us what will happen if we execute the command, and then we execute. So first step is to plan, and then is to execute. And to be able to plan, how can we do that? How can we get the plan? What would happen if I execute this? I would want to plan for it. I don't really want to execute it, but I would want to see the plan for it. How can I do that? The way I can do that is by saying Terraform plan. So if I do a Terraform plan, I'll get the details of what Terraform would do if I execute it. So you can see that it's doing a lot of things. We'll talk about what Terraform state is in the next step. For now, let's focus on the plan it would generate. This will take a little while, a couple of minutes, I think. Okay, there you go. Here it comes back, and it says Terraform will perform the following actions. What actions will it do? It will create a AWS S3 bucket. What are the details that it would use to create the AWS S3 bucket? It shows all the details in here. You can see that the bucket name will be this. So this is the name which will be used to create the bucket. And there are a lot of attributes which are shown in here, which will be known after apply. This is basically, these values will be known only after executing the command. Right now we are in the plan stage, so we don't know the value of this. We'll know it a little later. So over here you can see all the attributes of the S3 bucket that we are going to create. Most of these are actually default values because the only thing which we really configured is the bucket. Now let's go ahead and execute it. How do we execute it? Terraform apply. So let's do a Terraform apply. So apply is basically the execute command in Terraform. What it would do now is it would again generate the plan. So whatever plan which we saw earlier, it would again show it to us, and then it would ask us, do we want to apply this? It might take a little while. Okay, there you go. It's come back now, and you can see that it would create one resource. The plus in here indicates that it's an addition. We'll look at other options a little later. And over here, it's asking, do you want to perform these actions? Terraform will perform the actions described above. Only yes will be accepted to approve. So you need to enter yes in here if you'd want to execute it. So I'll enter yes and go ahead. So what is it trying to do right now? It would try and create the S3 bucket. So what we are doing right now is we are using Terraform to create a resource in AWS. Earlier we set the access keys into our exports. The creation of S3 bucket would take a little while. So let's wait for it to complete. Cool. The creation of the resource took about 52 seconds, and after it, I was able to see this screen that the resource is created. So our access keys are properly working, and we are able to create this bucket. Now let's go to S3 and let's refresh the screen. Will I be able to see the bucket? Yep. You can see that there is a new bucket which is created in here with the name my S3 bucket in 28 minutes Ranga K001. So that's cool. So now we were able to set up the AWS access keys, and we are able to create a resource in AWS using Terraform. There might be a number of questions at the back of your mind. We'll discuss all of them in the subsequent steps. Welcome back. In the previous step, we were able to successfully create a S3 bucket using Terraform. If you had any problems, make sure that the access keys are right and make sure that the bucket name is unique. Those are the two problems you might typically face. If you have problems, make sure that you have new access keys, and also make sure that you have a unique name for your bucket. So you can add a few random characters in here if you have problems with bucket names. Now, if you are able to execute the whole thing successfully, you should see a file called terraform.state in here. Right beside main.tf, there is a file created which is called terraform.state. And inside that, you should see a lot of JSON which is present. Now, what is use of this JSON? Let's look at it in this specific step. What I'll do now is I'll do a Terraform apply without making any changes to the bucket. So I'm not really making any changes to the bucket, and doing Terraform apply. What do you think will happen? This execution will take a little while. This would take about 30 seconds, I think. So let's wait for 30 seconds and see what would happen. You'll see that Terraform is able to recognize the fact that we did not make any changes and it actually does not perform any actions at all. So what you're seeing in here is right now it says something called refreshing state. What is refreshing state? We'll talk about it. For now, you'd see in a few seconds that Terraform would say there are no changes and therefore I'll not do anything about it. Cool, it took about 30-40 seconds and at the end of which it says apply completed and it says 0 resources are added, 0 are changed and 0 are destroyed. Basically it did not do any changes at all. How is Terraform able to recognize the fact that nothing has changed in your configuration? Let's take a step back and try and understand what is happening in here. In main.tf, in the Terraform scripts, what we specify is something called a desired state. I would want a S3 bucket. I would want 5 virtual servers. This is nothing but your desired state. So I would want this state in the cloud. The second thing is known state. Known state is the result of previous execution. When we executed Terraform apply earlier, Terraform created the S3 bucket and also it created something called terraform.state. It stores the state as it knows at the point in execution. Let's say this execution happened 2 days back. So this is the state as Terraform knows 2 days back. That is what is called a known state. And the actual state is whatever is the state of the bucket in AWS. Somebody might have actually went here and made a small change on the bucket. So there are 3 different states, right? So desired state is what we want. Known state is what is present in the terraform.tf state file, which is kind of a backup temporary place where Terraform stores the state information, basically the result of the previous executions. And the actual state is what is actually present in AWS. And when we do a Terraform apply, what Terraform does is it looks at the terraform.state. It looks at all the information which is present in here, looks at the fact that there are a few resources which were already created. So it knows that my S3 bucket with a bucket name, specific bucket name was created earlier. So it goes and checks what information is present in AWS about this specific bucket ID. So it uses this bucket ID, goes to AWS and asks, okay, what is the information which is present about this specific bucket in AWS? Has something changed? And that's what is called refreshing state. What it's doing is going to AWS, getting the state about that specific bucket. It's refreshing the state about that specific bucket. And then it realizes that there is no change. It realizes that the desired state, whatever we want in here, is exactly the same as the actual state which is present in AWS. And that's the reason why it does not make any changes at all. Now, let's make a small change in this bucket. Let's say I would want to change the bucket name from 001 to 002. I'll do a save and I'll do Terraform apply again. Let's see what would happen. This would also take a little while. It's currently refreshing the state. This I expect to take around 30 seconds. It took about 30 seconds and this is what it came back with. Now, what you see is it's saying Terraform will perform the following actions. It's saying my S3 bucket must be replaced. What it's saying is you are changing the name of the bucket. So what I would need to do is I would need to delete this and recreate this bucket again. Terraform is able to identify the fact that you cannot directly change the bucket name. So what it's doing is it's deleting the existing bucket and creating a new bucket for us. And it's telling there is one to add and one to destroy. Terraform will perform the actions described above. So what we'll do in here is go ahead and say yes. So let's see what would happen. So what it would do now is it would delete the old bucket and create a new bucket with the new name. So it's destroying the old bucket which had the name of Ranga K001 and it would create one with Ranga K002. So it took about 6 seconds for destruction. I think it would take about 30 seconds for creating it. It's about 1 minute and still it's in execution. When I went to AWS and refreshed the screen, I saw that there was already a bucket, my S3 bucket in 28 minutes Ranga K002. So it should be done. Yep, it's done right now. So it took about a minute and 11 seconds to create the bucket, and it says 1 added, 0 changed, and 1 destroyed. And if you look at the current state, what would be in the current state, known state of Terraform.tf state? You would see the details of 002 bucket. So what you can see is now the desired state is 002, the known state is 002, and the actual state is also 002. Now what I'll do is I'll make a small change in here. So if you look at the Terraform.tf state, right now the versioning is not enabled. So let's try and make that change. So I would want to enable versioning on this bucket. With versioning, what we'll be able to do is to store multiple versions of the same file over a period of time. So let's try and enable versioning in here. So versioning, the way we can enable it is by typing in versioning and within braces say enabled is equal to true. So we are enabling versioning. So let's see what would happen. So the desired state now is that versioning is enabled. The known state is whatever was the result of the previous execution. The actual state is whatever is in AWS. Let's see what would happen now. Terraform apply. As you can see right now, we are actually taking a shortcut. Ideally, you'd want to do a Terraform plan, look at the plan, and then do a Terraform apply with the plan that was generated. What we are doing is Terraform apply. The thing is, even Terraform apply would generate the plan. You'll be able to see the plan, and then you'll be able to type in yes. Cool. It took about 30 seconds and it came back with this thing. It's saying 1 to change, 0 to destroy. It's saying versioning enabled false to true. So earlier it was false, it now needs to change to true. So Terraform is able to compare the desired state with the actual state, and it's able to identify that this is the only thing which has changed and that's the only thing that needs to be modified. And now I can make that change by saying yes. So the existing resource is going to be changed to enable versioning. So this will take a little while as well. It took about 50 seconds, and after which I see that the change has been completed. And if I go into the bucket, so this is the bucket I created. The overview screen was where we were earlier. If you go to the properties screen, you can see that versioning for this bucket is enabled. So we were able to enable versioning using Terraform. How does Terraform work and why is state important? The way Terraform works is you define the desired state, the resources you would want to be created in the cloud in your terraform.tf files. You can have any number of .tf files and you can specify what is your desired state. And the result of the execution, each time you execute Terraform apply, the result of the execution is stored in something called a Terraform tf state files. That is what is called a known state. And the actual state is whatever is in the cloud. Somebody can actually go to the cloud provider and make a change down there, right? So that's the actual state. Typically, you don't want to directly go to a cloud provider, log into AWS and make a change. If a resource is being managed by Terraform, you'd want it to be continually managed by Terraform. If you want to make any changes to that bucket, you'd want to be able to make it from here. You don't want known state to be different from your actual state. One of the things that you are observing right now is Terraform is declarative in the sense that you are saying what should be the desired state, and Terraform is comparing against the actual state and identifying what are the differences. How can it actually synchronize the desired state to the actual state? And it's identifying the fact that versioning needs to be enabled and it made the change for you. So to make a change, you are not really executing code saying enable versioning. What you are saying is this is what I want, and Terraform would compare the desired state with the actual state and make sure that that happens for you. We'll talk a lot more about state a little later. For now, the important thing to understand is whatever you are defining in main.tf is the desired state, whatever is in the cloud is the actual state, and whatever is in the terraform.tf state is the known state. And whenever you are doing Terraform apply, what Terraform does is it tries to make the desired state actual. So it compares the desired state versus actual, it finds out the differences and applies them to make sure that the desired and the actual state are the same. I'll see you on the next step. Welcome back. In this step, let's look at something called Terraform console. Let's go to the terminal and type in Terraform console. You can see that a arrow mark comes up in here, and over here I can actually type in a lot of commands. Let's try and type in. You can use Terraform console to query about the current state. So let's say I would want to find out the details of this specific bucket. What I can do is I can say AWS S3 bucket dot my S3 bucket and type in enter. You can see that all the details of the bucket are shown in here. The syntax is very simple. This is also called a reference. What does the reference contain? This is the provider, this is the resource type, and this is the name of the resource in Terraform. So the name of the resource in Terraform is my S3 bucket. The thing is, we don't use the bucket name. What we use in Terraform is the name that we provide in here. You would see that we will create a lot of resources, and always in Terraform, whenever we want to refer to the resource, the name we will be using is the type of the object dot the name of the object. So AWS S3 bucket dot my S3 bucket. And once you type that in Terraform console, you can see all the details of that S3 bucket. So you can see the specific details. So you can see what is the domain name, what is the ID of that specific bucket. You can see which region we are creating it in. We are creating it in US East 1. And you can see if there are any tags and all that stuff. So if you go ahead and say AWS S3 bucket dot and say versioning. So you can use any of the attributes in here and try and find exact information, more detailed information. So I can say AWS S3 bucket dot my S3 bucket dot versioning, and you can see that it's enabled true. You can see that this specific thing is a list. How can you find out that this is a list? Because it's actually having a square brackets around the whole thing. So you can say versioning of 0. So this is the first element inside the array. So you can see that this is the first element inside that specific array. So I use 0 and identify this element. How do I access information from the map? The way I can do that is by saying dot enabled, and it says true. Now let's say I would want this information to be output from my Terraform apply. The way I can do that is by actually having something called a output from here. So I can say output and give a name. So let's call it my S3 bucket and versioning, and I can paste that in here. Value is equal to whatever we had from there. So let's do a full screen, Control B or Command B to go full screen, and over here you'd be able to see that we have defined an output variable in here, my S3 bucket versioning, value is equal to so and so. Now how can I see the value of the output variable? The way I can do that is go out of the Terraform console. So we are going out of the Terraform console and we are doing a Terraform apply. So we are doing an apply, and one of the things is if I do a Terraform apply as it is, it would try and refresh this state. I don't want the current state to be refreshed from the cloud, because I know that the current state and the actual state are the same. The only one thing I would want to find out is the value of this variable name, which is the output. So what I'll do is I'll say hyphen refresh is equal to false. So what I'm saying is do not refresh. Let's see what would happen. Terraform apply hyphen refresh is equal to false. So it compares the desired state directly against whatever state is present locally, and it would immediately return back. Cool. You can see that the refresh did not really happen, but it gives me the output. It says my S3 bucket versioning, it's true. We will use hyphen refresh is equal to false a few times because the refresh process is a little slow. But when you are really using it in production kind of scenarios, you should avoid hyphen refresh is equal to false. You don't want to depend on the known state that is present in the TF state file. You always want to check against whatever state is present on the cloud and then apply against that. Over here, what we are doing is we are disabling that check. Now, you can see that the outputs are provided in here. The interesting thing is you can actually have multiple output variables. So I can say output my S3 bucket versioning. In addition to that, I can actually output the complete details of the bucket. So I can say my S3 bucket complete details, and I would actually output the entire bucket as such, and I would execute the same command again. Let's see what would happen. Cool. It took a little while, and at the end of it, it showed the following output. So my S3 bucket complete details, it shows all the details of the bucket, and my S3 bucket version. So you can see that I can have two output variables from a Terraform script. In this quick step, we looked at two different things. We looked at Terraform console, where we would be able to query information about the known state, and we also looked at how to define output variables in your Terraform scripts. I'll see you in the next step. Until then, bye-bye. Welcome back. In this step, let's create a new resource. In the previous step, we created S3 bucket. Let's try and create an IAM user in this specific step. So how do we create an IAM user? Let's start with the resource definition for it. So I'll say resource type for IAM user is AWS IAM user. And the name I would want to give to this is my IAM user. So this is the name which we will be using to refer to it in Terraform. And over here, we can define the details of the IAM user. Let's say I would want to give it a name. The name I would want to give it is my IAM user. Let's say ABC. So I would want to create a IAM user with this specific name. Let's do a clear, and let's do a Terraform plan. The interesting thing is the Terraform plan output, you can actually store it to a file. So I'll say Terraform plan -out IAM.tf plan. Typically the extension which we use to store Terraform plans with is -tf plan. So what we are doing in here is Terraform plan -out IAM.tf plan. So we are storing the plan to output. So let's press enter right now. So Terraform plan -out IAM.tf plan. While the execution is in progress, one of the things you need to remember is that we are playing with very simple objects like S3 buckets, IAM users, to get familiar with Terraform. Later, we would actually create EC2 instances, which are virtual servers in the AWS, and also we'll create load balancers. So we'll get to complex things a little later. Let's try and understand the basic things around Terraform by using these two examples. We'll be using S3 buckets and IAM users to understand the basics. One of the things you can already see is the fact that every time you execute a Terraform command, it takes a long while because it refreshes the state and does a lot of things. So what we'll do is we'll play with the basic things, and at a later point in time, we'll go to the complex things like EC2 instances or the virtual server instances and the load balancers. For now, you can see that the Terraform plan was generated. And what does the Terraform plan tell us? It says that there is one resource that needs to be created. What is the resource? AWS IAM user dot my IAM user will be created. These are the details of this specific resource. Now, how can we apply that plan? The way we can apply that plan is by using the plan which we have already created. So you can actually see the command which is present already in here and execute it. So this is another way you can apply. So you can take the plan, save it, and then apply it. Or you can actually directly execute Terraform apply. For now, let's use the approach of using the plan file which was generated. So I'm executing Terraform apply IAM.tf plan. So now what does Terraform do? It will just use this plan and execute it. It would not do a compare of an desired state with the actual state. It directly takes this plan which was generated and tries to execute it. Let's see what would happen. So you can see that there is no comparison, there is no refresh of state or anything like that. It directly goes ahead and creates it. So you can see that the execution is faster because it's not really comparing the state. It chooses the plan file and goes ahead and creates the IAM user. So the IAM user is created for us right now. You can see that one resource is added. We did not output any details about the IAM user in here. So let's add another output saying IAM user details. So what I'll do is I'll go over to the outputs and I would be doing output. I'll say my IAM user complete details. And I would say over here my IAM user, and the resource type is AWS IAM user. Let's do a Terraform apply, and I'll say -refresh is equal to false. I don't really want to refresh because it would take a long time otherwise. So let's see the outputs right now. You'd see that there are 3 outputs right now: my S3 bucket versioning, my S3 bucket complete details, and my S3 user complete details. It took about 20 seconds and it came back with these results. So you can see that the outputs contain my IAM user complete details as well. So you can see that there is something called ARN. This is used to identify a resource uniquely in AWS. So AWS resource notation. Once you have this, you can uniquely identify any resource in AWS. So you can see all the details in the outputs. Now I can actually see the same details in Terraform console as well. So if I go to Terraform console and I actually pick up the thing from here, I can actually put those things in here: AWS IAM user dot my IAM user, and I'll be able to see the details of it. I can say .arn, and then I would be able to get the ARN alone. In this step, we created a new type of resource called AWS IAM user. We saw that Terraform was able to identify that we did not make any changes to S3 bucket, and it only created the IAM user for us. We also saw how to add an output variable and also tried to look at the IAM information from Terraform console. I'll see you in the next step. Welcome back. In this step, let's try and update the name of the user and see what would happen. Let's get started right now. So I'm changing the name to ABC updated. One of the things is Terraform is really intelligent. It knows that AWS S3 bucket, you cannot change the name of it. So if you change the name, you have to recreate the bucket again. And it knows that the name of a IAM user can be changed. Let's see how it would react right now. I'm updating the name of the user. I'll do exit. I was logged into Terraform console earlier. Let's do a clear and let's do a Terraform apply. And I'll take a shortcut in here. I know that the only resource I'm updating is this specific thing, right? So I don't want any changes to be done on the AWS S3 bucket. I only want changes on this specific thing. So what I'll do is I'll say -target is equal to and specify this resource. So AWS IAM user dot my IAM user. So what would happen is only this resource and dependent resources. For now, we don't really have any dependent resources on it. So only this specific resource will be updated. Let's see what would happen. Terraform apply -target AWS IAM user dot my IAM user. So you can see that only the state for that specific user is being updated. And now you can see that it says the plan is there is nothing to add. It needs to change one thing and 0 to destroy. So what does it do? You can see that this value name is going to be changed from my IAM user ABC to my IAM user ABC updated. You can see that Terraform is really intelligent. It understands the different resources. It knows that a bucket name cannot be changed. Once I create a bucket with a specific name, you cannot change it. And it knows that an IAM user's name can be changed. So it's intelligently deciding that instead of deleting and recreating the IAM user again, the fastest way would be to directly change the name of it. And it's suggesting that to us in the plan. And I would go ahead and say yes. And what does Terraform do right now? It performs the change. It executes the change and it would show us the result. The execution took about 15 seconds, and at the end of which I can see the output, and you can see that the ID and the name of this specific user has been updated. Now, if you go and look at the folder structure, you would see a file called terraform.tfstate and terraform.tfstate.backup. And if you open up the terraform.tfstate, there should be 2 different things that are defined. One is the user and the other one is the S3 bucket that we have created. Now, the terraform.state.backup, let's look at what is present in here. You can see that it contains the previous state. So it contains the backup of the previous state. So it contains my IAM user ABC, and Terraform.tf state contains my IAM user ABC updated. Now, whenever you successfully execute a Terraform apply, what would happen is the state before the execution of the command would be present in terraform.tf state.backup, and the state after the successful execution of the command is present in terraform.tf state. So the terraform.tf state.backup acts like a backup just in case your terraform.tf state gets corrupted. You can see what was the previous state in terraform.tf state.backup. One of the important things for you to remember is you should not make any changes to terraform.tf state directly. Now, as soon as I give the warning, what I'll do is I'll not follow it. So I'll do an enter in here. I'll not do changes to the file, to inside the file. What I'll do is I'll do .001. So I'm renaming the file to .001, and I'll again rename this as well to .backup.001. So I'm renaming the terraform.tf state and terraform.tf state.backup files, adding an extension 001. Now, if you do ls, I'm inside the directory where these files are present, 001 and backup.001. So there is no state present in the local. What does that mean? That means there is no known state. If there is no known state, Terraform cannot compare what is the known state with the actual state. So what does it do? Let's see what it does. Let's do a Terraform plan. So you can see that an execution plan has been generated. And what does it say? It says it would create two resources, my IAM user and my S3 bucket. Is that what we want? Why is this happening this way? Let's go ahead and actually rename. So I'll do an enter, and I rename the files back to what it was earlier. I'll do an enter and rename the files back to what it were. And now if you execute a Terraform plan, what would happen? Now Terraform would be able to use the known state, refresh the details from the actual state, and compare the changes against the desired state. It would see that desired and the actual states are the same. So it will say no changes. Why is the terraform.tf state important if the Terraform is able to actually get the state from the cloud directly? So the actual state is in the cloud. Why can't Terraform directly match the desired state as the actual state? Why is known state needed? To understand that, you need to understand how Terraform works. The most important detail in your Terraform configuration is the name that you are giving in here. So here I'm calling this user my IAM user. So as far as Terraform is concerned, this is the ID. This is the specific thing with which it identifies the user. So what it does is it uses this my IAM user. Whenever I run a Terraform plan, it goes here and checks for the my IAM user. So where is the my IAM user present? Let's search for it. This is the outputs. The resource is present in here. So inside the resources, there is a my IAM user, and it uses the ID of this specific resource. So it uses the ID of this resource to map it to the actual resource which is present in the cloud. If the terraform.tf state file is not present, Terraform has no way of knowing that the my IAM user matches to this unique ID. And therefore, it would think that you would want to create the resource again. So this state is very, very important. The important thing about the known state is the fact that it contains a mapping from the Terraform name of the resource to the AWS identifier of that specific resource. And when you execute a Terraform apply, Terraform would get the AWS identifier using the Terraform identifier, and then it would refresh the state from the actual state. But if the terraform.tf state does not exist, if there is no known state, then Terraform thinks there is nothing existing, and it would try and create everything again. Now, when I go to the command prompt, I see that the commands executed, the Terraform apply executed successfully without any changes. So no changes. It says infrastructure is up to date. This is because we actually renamed the files back to terraform.tf state and terraform.tf state.backup. In this step, we discussed the fact that Terraform is very, very intelligent. It knows that IAM user's name can be changed. So it did not try to delete the user and create it again. It updated an existing user. We also realized the fact that the terraform.tf state, that is the known state, the result of the previous execution, is also very, very important. Without it, Terraform would not know what a specific resource maps to on the cloud. So it tries to create the resource again. We'll talk a little bit more about state in the next step. Until then, bye-bye. Welcome back. In the previous step, we discussed the fact that Terraform.tf state is very, very important. Without it, Terraform will not be able to identify what is the known resource and refresh the actual values from the cloud. So if you have a project where multiple people are working, then you would want to share this Terraform state with them. So how can you share the state with them? Do you want to commit it to the GitHub repository? The thing is, committing the terraform.tf state or the terraform.tf state.backup to GitHub repository is a very, very bad idea. The thing is, if you are using any secrets to create the resources and things like that, all those values are stored unencrypted in the terraform.tf state file. And therefore, the content in the terraform.tf state should not be committed to any version control system. So if you cannot share this file, what should you do? The ideal way to handle Terraform state is to actually use something called a remote backend. We can store the Terraform state in a S3 bucket. So we'll store the Terraform state on the cloud. This would ensure that even if multiple developers execute it, they would get the latest state from the cloud, and the Terraform can compare against the actual state. We will look at how to implement a remote backend a little later in the course. But until then, the important thing for you to make sure is that never commit these two files and this folder. So the .terraform folder contains unnecessary files, so you don't really need to commit it to version control. And you don't want to commit terraform.tf state and terraform.tf state.backup to version control because they might contain sensitive information. And that's the reason why what we have done is in the project, in the git ignore files, we have added in these three things. So you can see that this tar.tf state, tar.tf state.backup, and .terraform. So any file ending with .tf state is excluded, and the same is the case with any file which is ending with tf state.backup. And we are excluding the complete Terraform folder. So this is very, very important whenever you execute any Terraform scripts, whenever you're creating a version control around your Terraform scripts, make sure that you follow this. In this step, we understood the fact that the local Terraform state, that is basically the known state, is very, very important. The known state maps the Terraform IDs to the IDs in the cloud. And without the known state, Terraform does not know what is the actual resource on the cloud. So if you delete the tf state files and try and execute the script again, Terraform would try to create the new resource again. We also discussed the fact that the Terraform state should not be shared because it can contain sensitive information. And we discussed the fact that a remote backend is the best option for storing Terraform state. We'll look at remote backend in one of the future sections. The other important thing we learned is the fact that these files have to be excluded in your .git ignore. So make sure that you always ignore these files in your git ignore so that these are not committed to your GitHub repository. I hope you are having an interesting time, and I'll see you in the next step. Until then, bye-bye. Welcome back. Until now, we are creating everything in our main.tf file. If there are hundreds of resources in the main.tf file, it would become really, really complex to maintain. And that's where we can actually separate them into separate tf files. How can we do that? Let's look at that in this specific step. Let's get started with actually separating the outputs into a separate file. So I'll do a Control B or Command B, and over here inside our Terraform basics folder, I'll do a right click and create a new file with the name outputs.tf. So we can create a outputs.tf, and oops, this is not what I want. I want to copy this. Actually, I did a cut, and let's go ahead and put it down here. So I'm moving the outputs.tf into the other file, right? So it's saved. Main.tf is also saved enough, and let's do a Terraform plan. I'll say -refresh is equal to false. So I don't want to refresh it. I just want to see the plan. I'm in the same directory where these files are present. So my current working directory, actually my present working directory is 01 Terraform basics. So you would see that the plan would refresh and there are no changes. The only thing that we did was actually move the outputs.tf into a separate file. So you can see that you get a feedback saying no changes, infrastructure is up to date. So you can see that all the Terraform configuration does not need to be in a single file. Actually, it does not even it does not even need to be named as main.tf. You can give it any name as long as you have a tf extension. So whenever you execute a tf plan or a tf apply command, what Terraform does is it kinds of concatenates all the tf files which are present in there. So it concatenates all of them and executes that. So it would take main.tf, outputs.tf, any other tf files which are present in there, concatenate all of them and try to execute that. So you can have 100 tf files which are present in this folder and all of them would be executed when you execute the Terraform plan or Terraform apply. I'll leave it as an exercise for you to actually take these and create a file called resources.tf. As we go further in the course and add a lot of Terraform configuration, you would see that this becomes really, really important. You'd want to be able to maintain this very well, and to be able to maintain that, it's better that they are in separated files. This marks the end of our first Terraform project, and what we'll do now is we'll destroy the resources that we have created. Whenever you use Terraform, you typically follow this cycle. You do a create, use, and then destroy. Because everything is automated, you can easily create it and destroy it. Let's say you are learning Terraform, right? So what you can do is whenever you start the day, whenever you start practicing with Terraform, you create resources. And once you are done with using the resources, all that you need to do is to execute a simple command, Terraform destroy. So you'd see that this would automatically destroy all the resources that we have created. Actually, by destroy we mean delete. So we have created two resources. One is the IAM user and the S3 bucket. You'd see that the Terraform destroy would actually delete them. So similar to Terraform apply, Terraform destroy also refreshes the state first. So it looks at the current state, identify what are the resources to be deleted, refreshes them, and then it would go ahead and delete them. Terraform destroyed continued execution, and now it shows us the plan. It took about 30 seconds and it said 2 to destroy. And if you look at the details, you'd see that there is a negative or a minus icon against each one of these. That means these all would be deleted. And I would say yes. So all the resources that we created were destroyed. It took about 15 seconds and we are all set. In this first project, we understood the Terraform basics. We understood how to create a resource, how to update a resource, how to terminate a resource, and we played with Terraform state. We understood the importance of Terraform.tf state files, and we understood the fact that in Terraform, there are 3 different kinds of state. The desired state, which is actually defined in the Terraform configuration files, the known state, which is present in the tf state files, and the actual state, which is actually the state of a specific resource on the cloud on AWS. We also looked at some of the important commands in Terraform, Terraform plan, Terraform apply, and we looked at Terraform console. The knowledge you gained in this project will be really, really useful as we go on in the course with Terraform. I'll see you in the next step. Until then, bye-bye. Welcome back. Let's now start creating a new Terraform project. What we want to do in this project is to create multiple users. In the previous step, we created one user. Let's see how to create multiple users and play around with it in this specific step. The reason why we are playing with users and not buckets is because users are much faster to play with. The IAM users are easily refreshed and created. Buckets take a long time to create. That's the reason why we would be playing with IAM users in this specific step. So how do I create a new Terraform project? All that I need to do is to create a new folder. As simple as that. So right click, new folder. I'll call this 02 Terraform. Actually, I'll call this 02 more Terraform basics. So, and over here, I'll create a new file, main.tf. So this is exactly what we did earlier. What I'll do is I'll go to the main.tf from earlier and copy the provider, and I would copy the whole thing which is present in here. Let's make it quick. So I'm copying the whole thing which is present in the 01 Terraform basics, and I'll delete that specific thing out. If you have any problems during this course, all the content will be present on the GitHub repository in the folder backup. So what I'll do is I'll create a folder called backup and move 01 Terraform basics also into it. So after creation of this project, so 02, 03, 04, I'll move all of them to backup so that you have a backup and you can refer to them on the GitHub repository whenever you need them. Let's continue to focus on 02 more Terraform basics. We have a provider AWS and we have a resource AWS IAM user, my IAM user. I don't want to create one user, I would want to create multiple users. That's why I'll call this my IAM users. And over here, what I would want to do is I would want to create two users. How can I create two users? With HCL, HashiCorp control language, it's very, very easy. Its count is equal to 2. So I would want to create two users. Now, how can I specify the name of the users? Think about this, right? Over here, I don't want to use the same user for both. How can I do that? The way you can do that is actually just use the dollar, open brace, close brace. So I'm saying underscore, dollar, open brace, close brace. I'll remove the updated and the ABC. So my IAM user, and I'll put the index in here. So index of what? Count dot index. So this is a syntax which is supported by HCL, where you can actually say I would want two resources and I would want to use the index of the resource to create the resource. So the first resource will be created with the name my IAM user underscore 1. The second resource will be created with the name my IAM user underscore 2. Now, can I directly go in and execute it? What's the present working directory? 01. So let's do a .02. Oops, actually, let's do a cd. We have deleted that folder. That's the reason why I'm unable to use that. So /02, and now I'll be able to see the file which we have created, main.tf. Can I do Terraform plan or apply directly? This is a new project, right? First thing I would need to do is Terraform init. So this would actually download the providers. So the AWS provider which we are using, it would be downloaded. It would take a little while for the provider to be downloaded. Cool. The Terraform has been successfully initialized, and now I can do a Terraform apply. I could also do a plan and copy the output to a file and do an apply with the file as well. What do you think Terraform would do right now? Terraform now tells us that it would create two resources. So two to add. What are the details of it? So it says I'll create a user called my IAM users of 0, and the name of it is my IAM user underscore 0, and my IAM users of 1, and the name of it is my IAM user 1. Cool. That's cool. So let's go ahead and say yes. So this would create two IAM users for us. Cool. Two resources are now created. If you go on to services, IAM, you should see these two users present down there. You can see that there are 4 users, and these two, my IAM user 0, my IAM user 1. One of the things I would recommend you to do is to look at the Terraform documentation. If you just do a Google for Terraform IAM user or Terraform S3 bucket, you'd land up on the documentation for that specific resource, and you'd get all the things that you can configure for that specific thing. You can see that for IAM user, you can configure a name, a path, you can give it a lot of tags, and you can also attach a policy saying what are the permissions that you would want to attach with that specific resource. So I would recommend you to actually look at the different things related to that resource. One of the things is to be able to make use of this resource, you need to understand AWS as well. So that's a small complexity which is present, but make sure that you look at it, you play around with the documentation. I really love the Terraform documentation because it provides really, really good examples, and it provides good documentation around the different arguments and attributes as well. Now, let's say I would want to increase the number of resources to 3. What would happen? Let's say I would want to make it 3. So let's do a Terraform apply again. What do you think will happen? Well, Terraform will be able to identify that I would want to have one more resource. Will it be leaving the 2 as is, or will it be trying to delete them? let's see what would happen. One of the things you are already noticing is the declarative nature of Terraform, right? So I'm saying I need 3 resources. I'm not saying I would want to add 1 resource, right? So I'm saying I would want 3 resources in total, and Terraform is going and checking the state. So it's seeing that there are 2 existing users. So what it does is it says 1 user will be created. My IAM users of 2 will be created, and it says these are the details. Do you want to go ahead and do that? Yes. So Terraform, as we said until now, is very, very declarative. As soon as you say I need 3 users, it would go and check the state. It sees that there are 2 users already present, so it's only creating the 3rd user. In this step, we learned how to create multiple resources with Terraform. I'll see you in the next step. Welcome back. In this step, let's play around with a few more Terraform commands. I'm in the present working directory of 0402 more Terraform basics. So let's do a clear, and I'll do a Terraform console. So we have been using Terraform console a number of times until now. So let's go ahead and do Terraform console. What can I do? I can get the details of the resources, right? So AWS IAM users dot my IAM users. What is this type? You can see that the type of this is a list. So you can see that there is a square bracket around this. Within the list, there are multiple objects present, and I can access a specific object by using an index. So I can say of 0 and dot ARN. So what does it do? It gets the index of the first user, the ARN of the first user. If I do a 2.ARN, it gets the ARN of the 3rd user. And you can actually play around with all the other details as well. So you can say dot name or dot path. So this is very, very useful if you want to send something to the output. You'd want to define something as an output variable. You can play around with it in console and then go ahead and define an output variable. So a console is really, really useful. You can play around with the different values which are present. You can look at what is present in Terraform state and use them to execute a few commands. Let's do exit. And over here, what I'll try and do here is introduce an error. So I'll remove the X, so INDE. You can do a Terraform validate. So Terraform validate is one of the commands which would be useful to validate whether the Terraform script is valid. So it's saying invalid count attribute. So it's saying count does not have an attribute called index. So I'll need to add a X in here. So if you provide an invalid resource name, let's see what Terraform does. Terraform validate. Cool. It says invalid resource type. So if you want to test a few things, check whether the script is good or not, you can do a Terraform validate. The other interesting command which is present in Terraform is Terraform. Let's say I do the unformatting of this. So I'm formatting it in a different way. I can say Terraform format. What does it do? It formats it. So you can see that it formats it with 2 spaces. So typically, whenever we are using HCL, the recommended thing is to use 2 spaces. So the tab is actually 2 spaces, and you can easily get that by doing Terraform format. If there are 5 or 6 Terraform files which are present in here, all of them will be formatted. So typically, you can do a Terraform format before you commit it into your repository. The other interesting command is Terraform show. Terraform show shows what is in the state. It provides human readable output on the current state which is present in the state file. Currently, the file which we are talking about is terraform.tf state. So it provides a human readable format of this terraform.tf state. You can see that there are 3 resources present right now, and you can see all the details of those 3 resources right now. If you do a Google for Terraform apply documentation, you'd go to this page, Terraform apply documentation, where you can see all the options that are present for Terraform apply. We have been using this command a number of times. You can see that there are a lot of options that Terraform apply provides. So we earlier used Terraform apply, and also we used Terraform apply with a plan file. So we said we created a plan using Terraform plan. So the way we did that was using Terraform plan, and we said the output has to be saved to a sum.tf plan file. So I can say IAM.tf plan file. And once we do this, once the IAM.tf plan file is created, I can do a Terraform apply iam.tf plan file. That's the plan file which is being referred in here. Terraform also offers a lot of other options. If you do a Terraform apply, if you want to automatically approve it without asking you, you can do a -auto approve. The other interesting option in here is parallelism is equal to n. Terraform can actually create resources in parallel. We'll look at that a little later. You can configure how many maximum concurrent operations Terraform can perform. You can configure refresh is equal to true, refresh is equal to false. We have already used this. You can also configure the state path. Until now, we have been seeing terraform.tf state. So that's the default. If you want a different name, then you can configure that in here as well. We earlier also used the -target is equal to resource. If you don't want everything to be updated, you only want a specific resource to be updated, you can use the -target is equal to resource. There are a few options which are related to variables, which we'll be looking at a little later. Terraform is all about creating different resources in the cloud, and Terraform provides excellent documentation. So I would recommend you to check the documentation out and spend some time with it, and I'll see you in the next step. Welcome back. One of the important things about creating resources in the cloud is how fast can we recover from errors. Let's say we made a mistake. How fast can we recover from it? How easy to update the script and fix the problem? With Terraform, the thing is, it's really easy. Let's say I made a mistake. I gave the name as my IAM user. What happens? Let's do a Terraform apply. This would identify that the name has changed. However, Terraform does not know the fact that you cannot have multiple users on AWS with the same name. So let's see how it reacts in the case of this error and how you can actually recover from that specific error. So you can see that it's doing a refresh state. The thing which you can see is the states of all the 3 users are refreshed in parallel. Terraform knows that these resources are all independent, so it refreshes all of them in parallel. And you can see that it's saying 3 to change. So it's trying to update all the 3 names to my IAM user. Let's see what would happen. I'll say yes. So it will update the first one, and when it tries to update the rest of the 2, what would happen? It would fail. So when it's trying to update the second user's name, it would fail. One of the users should be successfully updated, the other 2 should fail. So you can see that one user is successfully updated and the other 2 users have failed completely. So entity already exists, so a name with that specific thing already exists, so you cannot have 2 users with the same name. That's the reason why it is failing. If you go to IAM management console, where we can look at all the users, what are the details that we would see? You'd see that there are 3 users, and I have a my IAM user, my IAM user 1, my IAM user 2. So you can see that there is no rollback that is happening. So it is left in this state as it failed. And next, what I can do is I can make the correction. So I'm making the correction. So I'm undoing the change that we did. And then I would do a Terraform apply again. What does Terraform do? It would compare the existing state with the actual state, and it would find that one of the users is updated with a wrong name. So it would fix it and it would update that specific user with the right name. I would say yes, it took about 5 seconds, 10 seconds, I think, something like that. I said yes, and you would see that it would update just this specific user to the right value. In this step, we saw what happens when there's an error in a Terraform script. We saw that it was really easy to recover from errors with Terraform.
This course teaches you Docker, Kubernetes, Azure DevOps, Jenkins, Terraform, and Ansible, the 6 most popular DevOps tools today, and you can run them in multiple clouds. So that's a course I would recommend you to check out if you are interested in going deep with DevOps.